So we're going to be talking about a little bit more complex factoring with our trinomials today. What I've got here, we're multiplying two binomials here, and we're multiplying two binomials here. So this is the stuff we were doing. We were factoring the trinomial that is created when we multiply these two. We were factoring it back into this. And now what we want to do is when we multiply something like this out, where we've got a coefficient here other than 1 and a coefficient here other than 1, we want to be able to factor that trinomial back to these two binomials. So let's just look at what happens when we multiply this out. We've already done something like this, and we'll look at what happens when we multiply these out, and then hopefully we can come up with a process. So when I multiply this out, I get, x squared, not red, x squared plus, and then 6x plus 4x plus 24. And then what we would do is we'd add our like terms together. We get x squared plus 10x plus 24. Okay, and what we would do if we were presented with this trinomial and I say, okay, factor that, and then you'd be basically working backwards and trying to get up to the product of these two binomials. So you'd say the factors of 24 that add up to 10. Let's take a look at what these numbers up here are made up of. Basically, what are their factors? So the 24, this is 2 times 2 times 2 times 3. So I'm just writing the prime factorization of each. This is 2 times 2. This is 2 times 3. What you'll notice is that the factors of the 6 and the 4, the 2 times 3 and the 2 times 2, are here as well. 2 times 2 times 2 times 3. And that's important to notice because that's why this works when we say the factors of 24 that add up to 10. Because once we get these two factors, 4 and 6, then we add them up and we get this. We're going to do something similar over here as well, except that we're going to have the 5 and the 2 that we have to worry about. Because here we just have 1 and a 1, and those are within these lists of factors here. We just don't show them ever. So that's kind of our strategy moving forward. And also, where do these numbers come from? Well, they come from up here. The 4 and the 6 are obviously here and here, and then the 24 comes from the product of the 4 and the 6. And so let's do the same thing. We'll multiply this out over on the right-hand side here. So I've got 5x times 2x, that's 10x squared. Plus, and then 5x times 3, that's 15x, plus, and then 7 times 2x is 14x, plus 7 times 3 is 21. So I have 10x squared plus 29x plus 21. So there's our trinomial that pretty soon here I'm going to ask you to factor a trinomial like this back to the product of two binomials. So let's list, like we did in the first one, let's list what the prime factorization for each of these guys are here. So this is 7 times 3, this is 7 times 2, this is 3 times 5, and this is 2 times 5. And in the interest of time, what you'll notice is that all the factors in the middle, these two and these two, 3 times 5 and 7 times 2, also appear on the outside. So I have 2 times 5 times 3 times 7, and I have 2 times 5 times 3 times 7. So if I were to take this number, which is the 21 and the 10, so here and here, and I multiply those together, I would get a number that would have all the factors that are in these two numbers, kind of like what we had over here. So it's almost like over here what we were doing is we were saying, okay, well, let's multiply this number times the coefficient here, which is what we were just saying to do here, 21 times 10. 24 times 1 is just 24, so that's why it was working before. We were basically doing the same thing as we're going to do right now to list our factors. So it's going to be factors of this times this, which is 21 times 10. So factors of 210 that are going to add up to 29. So that's our new process of going through this. So if I asked you to factor 10x squared plus 29x plus 21, we can do that over here. We'll list our factors. So it's factors of, and now we're going to do this number 21 times this coefficient up here times 10. So that's 210, factors of 210 that add up to 29. And we already know that it's going to be 14 and 15 because they are listed right here. But that would be, you'd have to go through that process and find out, you'd have to list factors of 210, and then hopefully find the one that adds up to 29. So these add up to 29, so that works. So now I just do the same process as before, 10x squared plus, and I replace the 29x with 14x plus 15x, and then still write that plus 21. Now this is where using that box or the Punnett square comes in handy. It helps out a lot. So I need to erase. I'm just going to erase and make some room over here. Okay. So I have in that box, I am going to place 10x squared, 14x, 15x, and 21. So now I have to figure out, when I look at this spot and this spot, it's not as simple just like x and x, because this is always x squared as they previously were. Now this could be 10x and 1x, this could be 2x and 5x, this could be 5x and 2x. So there's more possibilities here and here in this first spot. So if I put a 5x here, and then it would be 5x times what would give me 14x, and that's, we could figure it out, but it wouldn't be an integer. So let's try it here, 5x here. Ooh, I can multiply that by 3. So we'll put the 5x there, and then that means 2x has to go here. Can we make that work? Yes, we can, because 2x times 7 is 14x, 5x times 3 is 15x, and then 3 times 7 is 21. So we've got our two binomials, 5x plus 7, and then 2x plus 3 for our other binomial, and there we go. We have successfully factored that trinomial. All right, let's factor this trinomial into a product of two binomials. So our first step, I think I'll just write it as an addition statement, because that does help us to identify our terms a little bit better. So I've got 2n squared plus negative 27n plus negative 45. So this is going to be factors of, and I have to multiply this by this 2. So factors of negative 90. Negative 45 times 2 is negative 90. So factors of negative 90 that add up to negative 27. And that negative 27 is right there. Okay. Factors of negative 90, so this is going to be negative 30 and 3, and that adds up to negative 27, so that works. So I'm going to, same process as before, I'm going to replace this negative 27n with negative 30n plus 3n. So it's 2n squared plus negative 30n plus 3n, and then plus negative 45. Now I'm going to take those four terms, place them into the box in order: 2n squared, negative 30n, 3n, and negative 45. And now I just have to decide, where do these things go? So it's going to be 2n times n for this. So the 2n will go here and the n will go here. That'll make things easier. So we've got 2n and n. And then n times 3 will give us 3n. 2n times negative 15 will give us negative 30n, and then 3 times negative 15 is negative 45. So that works. So we've got negative n minus 15, and then times 2n plus 3. And that is our factored version of the original trinomial. I realize this process is a little bit different just because of the first part, but I think I'll stop there And if you guys have questions, bring them into class and we'll talk about them.